Hi everyone, welcome to Introduction to Inverse Functions. Before we get started, we want to first understand what inverse functions are. And so here we see, just ignore this part for now, here we see this function. I'm sure most of you have seen this here. It is a function. If you ignore this, it looks like the linear function where y is equal to mx plus b. And some of you may have even seen f of x equals to m of mx plus b. Here you can see that it is like a ratio of f and then x colon x. But basically that is just the same thing. That is exactly the same thing as f of x. This and this are the same thing, and so is this. A lot of times when you see this, it's more like a general function. This one here is more specific because sometimes there are questions that ask for different kinds of function like g of x. That's why we use f of x sometimes. And so here, this here exactly looks like the linear function. That's a good thing to know that. Now we want to know, it says find f of negative 1x. Now whenever you see something like this, it always means that it wants to find the inverse. We know that f of x itself is this one here. Now it asks for f of negative 1x. So again, whenever you see this, that means that we want to find the inverse. Now how do we find the inverse? So whenever we find the inverse, we want to first switch the places. We want to first switch the x and the y. So let me rewrite this as y equals to 2x plus 5. And when we want to find the inverse, we know that this is f of x. Now we want f of negative 1x. That would be equal to x equals 2y plus 5. Now you notice that I switched the x and y together because that's the first step that we need to do in order to find the inverse. Now we're not done yet because we want to rewrite it as y by itself so that we have a clear graph. And so algebraically, we'll move the 5 to the other side. It becomes x minus 5 equals to 2y. To leave the y alone, I need to divide both sides by 2. Now I have y itself. I can also rewrite this on the left-hand side so that it's clear because a lot of times we put the y on the left-hand side. And so here is our inverse. And so that's already the first step done. Now here for the second step, we want to sketch y equals to f of x. Now again, f of x is this one here. So basically if I draw a graph here, let me just and actually wait, I'll do it like this. So remember when you want to graph f of x, y equals to 2x plus 5, remember that the 2 is representing the slope and the 5 represents the y-intercept. So let's say 1, 2, 3, 4, 5. Is that too high? Yeah, I'll make it like this. 1, 2, 3, 4, 5. And so let me use another color. You can use blue for this. So blue for f of x, and then purple for f of negative 1x, and then black for y equals to x. Because if you take a look at number 2, it says we need to sketch f of x, we need to sketch f of negative x, and we need to sketch y equals to x. Now, let's first graph y equals to x. Now, we all know that y equals to x is basically like a symmetrical line between both axes. So just roughly y equals to x would be something like this, because if you think about it, if y equals to 1, then x would also be equal to 1. So it would be symmetrical. It's kind of like a square if you draw out. And if y equals to 2, x is also equal to 2. And so we can just roughly graph y equals to x, and I'll explain more how this line here helps us improve our understanding of graphing the two different functions, the inverse and the regular f of x. And so now let's try graphing f of x. So again, as I said earlier, the 2 represents the slope, so we would know that it is kind of more steeper than usual. But be careful now. We have 5 here. So that means the y-intercept is 5. So I need to move this up. So this would be, oh my gosh. This would be something like this. And let me first erase this. Feel free to skip the video ahead. Okay, and we graphed, just roughly graphed f of x. Let's label this so that it is clear. This is f of x. This is y equals to x. Now, you can also, there's another way to graph it. If you're unsure of the slope and the y-intercept, you can always use like a table data to graph the points. So let's say if I want to solve for if x equals to 1, we want to know x equals to 1, what y would be. We can always plot x equals to 1 plus 5 equals to y. Y would be 2 plus 5, which is 7. So if you take a look here, it kind of looks like 7. So yeah, you can also do this way, but it is much slower. I would definitely recommend you to, especially if it's a linear equation, since linear equations tend to be easier because you always know that y equals to mx plus b, where m is always the slope and b is always the y-intercept. And you can always just graph it like that. And if you're not sure, you can always plot points as well. Now, moving on to sketching the f of negative x, which is the inverse. Here, you can see that this is our inverse. And maybe some of you might think that, oh, this does not really look like mx plus b, but we can always just structure it again. Basically, it's the same thing. If you write it as x over 2 minus 5 over 2, it's literally the same thing as x minus 5 divided by 2. You can separate them if they have a common denominator together. And so another way you can rewrite this, you can also write it as 1/2 x minus 5 over 2. That way it will look more like mx plus y equals to mx plus b. And so here you can see that the 1 over 2 is kind of less steeper, right? It should be less steeper than the normal one, so it should look something like that. And we know that the y-intercept would be 5 over 2, which is approximately, if you want to divide 5 over 2, you get like 2 point something, so it'd be slightly more than 2. So it would be around here, or maybe slightly above, yeah, here. This is just approximately, so you don't have to worry too much about graphing the exact points because it's just sketching. You don't have to plot the points in. And again, the slope is 1 over 2, which is less steep, which is more, should be less steeper than y equals to x. So it should look something like this, or it should look, it should look something like this. Yeah. And you can see that they both intersect at the same point. And if you take a look at the relationship between f of x and f of negative 1x, you'll see that they're both symmetrical. If you look at based on the y equals to x, you can see that they're quite symmetrical. and you might need to tilt your head to see because the y equals to x is diagonal line, and you can see that, let's say this is the middle, right? If this is the middle, then they're both mirrored. F of x is mirrored against f of negative x. And so this is a special way to also graph f of negative x. Instead of rewriting it and plotting points, you can just draw it out as a symmetrical, a mirrored version of f of x. You can also do that. And so this is a quick way to do it. You don't even need to find the inverse. You don't even need to do any of this to graph it, because you know that it's always going to be mirrored against y equals to x. And so that's a way to do it, but of course I'm doing this because for the video, and also because question 1 asks for finding the inverse. And for question 3, it says show that f of negative x equals to f of negative 1 of f of x equals to x. Now I know what I said was kind of confusing, but remember from the past video I talked about composite functions. So first of all, let's dig this out. First of all, f of negative 1 x is the same thing as f of negative 1x. So there's a function inside another function. And how we can do that is by always plotting the inside first. So f of negative 1x, as we have solved before, is equal to x minus 5 divided by 2. Now remember, anything inside here, you can think of it as f of x, right? And this version here, you can see that inside is the x. So that means this here, the whole thing, the whole fraction here is equal to x for the function f. So the function f, which is the normal one, is 2x plus 5. And we plot this whole thing into the x. We substitute it. So 2 times, instead of writing it as x, you put it as x minus 5 divided by 2, because I'm substituting this into x plus 5. And so I get 2 times x minus 10 divided by 2 plus 5. And for this, I would want to, another way you can do it, this way is more complicated if you expand it, but you can also do it this way. You can cross out the 2, because 2 times anything over 2, we can just eliminate them. So we get x minus 5 plus 5, which is just going to be equal to x, because negative 5 plus 5 is 0, so it's just equal to x. Now let's try doing the other one. We finished doing this one. Now let's do f of negative 1 of f of x. And here again, this is the same thing as f of negative 1 of f of x. This time you can see that it's different. Instead, the inside is the normal function, the f of x. So let's plot that. First, we know that f of x is 2x plus 5. You can double check that by going up there. It says it is 2x plus 5. And so we know that, again, this is the same thing. F of negative 1x, we basically substitute the x as 2x plus 5. So remember, our equation for the inverse is y equals to x minus 5 divided by 2. And so, again, we plot this whole equation here into x. So it will become 2x plus 5 minus 5 divided by 2. And we get 2x over 2, because 5 minus 5 is 0, so 2x over 2 is the same thing as 2, because we're eliminating them. And so here you can see a special pattern, right? Both of them are equal to x. That means they are from the same function. It says that they're identity function. We want to show that they're identical, except that they're just inverse, but they're the same functions, except that they're just inverses. And so here, when you get our answers as x, this shows that what we're solving, they both come from the same function, except that they are both algebraically changed and they're both inverses. And so this is how we can solve and sketch for the inverse function. Thank you for watching.